Okay, we're still talking about the hardware and software requirements for the virtualization we're going to be doing. There's a couple of different terms that we're going to use in this course that end in address translation, and it's important that you not get them confused. Network address translation is a networking thing, which you should hopefully be familiar with from your Cisco or TCP/IP courses. Um, it's the process by which we hide, as it were, one IP address behind another, usually a private and non-routable IP address behind a public address. But it is possible to hide one public address behind another, or one private range behind a different private range for whatever reason. Anywho, second level address translation is not that. Second level address translation is related to virtual memory management. It increases our VM performance. The other thing we need to think about is storage requirements. Um, you need to be able to accommodate all of the virtual hard drives that you're going to build. Now, one way to do this without completely populating your hard drive with effectively empty space um, is what we call thin provisioning. We'll talk more about that later. But essentially, if you tell a VM that it has a 20 gig hard drive, it doesn't necessarily have to have all 20 of those gigs wrapped up in that virtual hard drive file. It could be much smaller than that. And particularly if you're not going to use all those 20 gigs, that's a really good idea. Um, but you do need to sum all of your storage requirements. Now, worst case, think about this in terms of worst case. Assume that you literally do need all of those drives. Now, for maximum performance, you might want to do what we call thick provisioning, which is to just earmark the whole thing at once. Thin provision is what we've done most of the time so far. Um, the VM thinks it has a hard drive of size X, but the VHD file is actually some fraction of that. But you really do need to sum all those up so that just in case all of your VMs max out their drive space, you don't run out of physical drive space. There are some storage options here. Um, we could do this with local disk storage. You could do this with a portable hard drive. I do not suggest running VMs off a USB stick. I've tried it a few times, and I've tried also moving them around that way, and that really doesn't work. Cloud storage also has proven to be a bit dodgy. I had some VMs, not this last semester, but the semester before, some VMs that I built for my Linux class, and I had them living on my Google Drive, and keeping them so I could work on them in the office and work from them here on my laptop at home. And really, it didn't work. They wouldn't stay in sync with I had to really think about making sure they wouldn't clobber each other by trying to stay in sync. Because the thing about Google Backup and Sync is it tries to upload all your files at the same time. So if you've got a computer at home which is up and Google Drive and Sync is running, and a computer in the office doing the same thing, and they both think they have a valid copy of the same virtual machine, they might be trying to overwrite each other. Not a good idea. Also, you're talking about pulling multi-gigabyte files down over a network and over a WAN link, an ISP link. Also not a good idea. You can make it work, but really and truly a consumer grade cloud solution like Google Drive is not the best solution for that. Now we are going to talk about cloud storage and the relevance of virtualization to cloud computing. And the short story there is that cloud computing as we understand today is literally impossible without virtualization. And there are actually cloud options. Things like VMware vCloud, Microsoft Azure, Amazon Web Services, the ECC suite. Anyway, so you can also do things like data center virtualization. You could have a whole bunch of VMs living on, say, a SAN, storage area network, or even a virtual SAN, a vSAN, inside Hyper-V, it's vSphere or Hyper-V. If you've got a lot, if you're going in more of a data center direction with this server farm, you probably are going to think more in terms of network storage. But of course, in that case, you're talking about really big hard drives, really big hard drives, really fast hard drives, sitting on the other end of a really good network connection, say fiber channel over Ethernet, or 10 gig Ethernet, or 1 gig gigabit Ethernet, 10 gig E, even 40 gig E. So we're talking about lots and lots of bandwidth. So you don't have a bottleneck pulling this VM down across the net in order to run it. Now, you can configure your VMs to use the host network interfaces. You can also do a lot more complicated things. LAN segments, virtual switching. There's a couple. We'll deal with that in more detail. But you need to think about the security and and networking needs of your VMs, so you build those correctly. And now let's talk about licensing as well, because licensing is another key part of this. Your packages are either licensed or open source. Now, as a general rule, your free version is not going to be as feature complete, even for a vendor who's mostly open source, say VMware. With Microsoft and Hyper-V, get the license. There's really no. You might get a little functionality out of the free version of things, but really and truly, in order to keep yourself good and legal, and this is one of those other risk management things that you have to think about in terms of overall system security. Make sure your software is legal, not pirated, licensed, that you have a right to use it. One of the other things that running having the license gets you in a lot of cases is support. You can find a lot of advice on how to run these things on the internet, but not all that advice is good. It would be a much better idea, particularly if you're going to have to pay for the license anyway. Particularly if that's a license that entitles you to professional, higher level vendor support. Absolutely go for it. We do all this. I say all this because, as far as the VM is concerned, it's a real machine. It has real licensing requirements. If you've ever started a Windows virtual machine and you haven't fitted a product key, you might notice that thing down in the corner that says "Activate Now." You might have trouble updating Windows if you don't have a valid license key. Now, if you're dealing with, say, a 128-day evaluation copy or something like that, you've got a little bit of a grace period before you do that. But eventually, you're going to need to license the software so you can update the software. And that's another patch management security thing that you really do need to be thinking about. Every piece of software comes out of the box with vulnerabilities. Good vendors are patching those things as they go. But if you don't have a valid copy of the software you're using, you're not entitled to the patches. So as time goes by, you're getting less and less secure, because in the interim between you pulling the software out of the box and you running the software on day X, the vendor has patched it. Also, the guys who make their living buying and selling exploits and things on the dark web have found ways to get into some of this stuff, potentially. Maybe there's a zero-day exploit that nobody knows is there, that nobody knows how to exploit, but that's security through obscurity, which is never a good strategy. Next time we'll talk, in the next segment, we'll talk about categories and products. Thanks for watching.